So far, we've learned arithmetic and geometric sequence and series. Now we're going to place our focus on geometric sequence once again because it has a wide variety of real-life applications. Now, I want you to look at these two formula. Do you find any similarities? The first formula is, of course, from geometric sequence that we've learned. And the second one is a formula for what is called exponential function. So this one right there. They are essentially the same, except they're using different letters or symbols. In other words, a geometric sequence is an example of an exponential function. They are the same thing, but just different names. So we are going to focus on this exponential function in this unit. In exponential function, this k right here, let's see, where's that? K represents the initial value, and we'll talk a little bit more about that. R also represents the rate of growth or decay. And also, we will talk about the difference between growth and decay problem. Okay. And T represents the time. I want you to notice one big difference there, that we do not need to subtract 1. So I'm talking about right here. When we were talking about geometric sequence, we had to subtract 1 to the exponent. But for exponential function, it's just t. You do not need to subtract 1 because the first term is actually the beginning value. So that's going to be year 0 or term 0. And then the second term is going to be actually the first term. So to offset that, we do not need to subtract 1. If that made any sense to you, but at least please remember that when we deal with exponential function problems, we do not need to subtract 1 for the exponent. Now let's jump right into an example. Okay, so here it is. Let's say that you own a rabbit farm. There are 50 rabbits right now, and the population of rabbits are increasing 7% each week. And the question is, how many rabbits are you going to end up having after 15 weeks, according to this model? Okay. So now let's identify those 3 components, 3 variables: k, initial value, r, and t. Okay, so k is the initial value that we just talked about. Now, how many rabbits do we have at initial stage? And that's 50 rabbits. So it's pretty easy. K is going to be 50. Now, R is going to be the most challenging, complicated one of all 3 variables. Okay, now it's increasing at 7%. Now, in order to figure out what R is going to be, we have to do 2 things. First one is, right here, we need to convert percent to decimal. We cannot just be using straight percentage. So we're going to, in order to do that, we are going to divide percentage by 100 because 7% means it's 7 out of 100, isn't it? So you do 7 divided by 100. It's going to be 0.07. I bet some of you knew that intuitively right away. 7% is 0.07. Okay. Now next we have to, it says add 1. Now why is that? Well, let's actually first of all do that. So you're going to do 0.07 plus 1, which is going to be 1.07. Now, what is that 1 doing there? Now, 1 in percentage. What is 1 in percentage? 1 is 100%, isn't it? If you have one whole of something, that's 100%. Because we're going to use 1.07, which means 107%. Because we want to carry over all 50 rabbits next week and week after, right? So we want to carry over all 100% and plus 7% more to it. So we just don't want to have 7%. We just want to have all 100% of rabbit and 7%. So we have to have that 1 in front of that percentage. Okay, so the R value is going to be 1.07. Okay, and the rest is pretty straightforward. T is the time. How long are we going to keep doing this? It's 15 weeks. So the T is going to be 15. So now we've got all the ingredients here. So let's set up the equation. Y equals, so here's the equation pattern. What's K? K is 50 and times, what's R? 1.07 to the, what's T? 15th power. And that will get you the population of the rabbit after 15 weeks. So please take out your calculator. And what do you get? You get 137.9. So let's round off to the whole number. 138. And what's the unit? We're talking about the number of rabbits. So according to this model, you should have about 138 rabbits with a 7% increase. Okay. Let's do another example. Okay. So let's say you inherited $2,500, or you made $2,500. Okay. Now you decided to put that money into the bank, and the bank says to you, we will give you 3.5% annual interest. Okay. And then you decided that you're just going to leave it for the whole 18 years without pulling any amount of monies. Okay. You're just going to forget about it for 18 years. Now, with a 3.5% interest rate, how much will you end up having? Okay, so that's the question. Okay. So let's identify those 3 letters. K, R, and T. Okay, so what is the K? K is the initial value. How much do you start with? It's 2,500. Okay, now R is, it's the 3.5% increase. Okay, interest means that you're gonna receive it. Your money is gonna grow. Okay, so 3.5%. Now, what do we need to do? We need to do 2 things. Can you remember that? Let's just quickly review. We have to do 2 things. First is you convert percent to decimal. And how do you convert it? You're going to convert the percent by 100. And then we're just going to add 1 to it. Okay, those 2 things. So let's divide 3.5%, that's percentage, by 100. That will convert into decimal form, which is 0.035. And then what's the second thing that you have to do? You add 1. So if you add 1 to it, you're going to get 1.035. Okay, so that is going to be the R value. And T is the time. And in this case, it's 18 years. So T is going to be 18. So let's set up an equation. Y equals, what's K? 2,500. And then R is 1.035 to the 18th power. So please take out your calculator and do that. And I've got $4,643.72. Okay, and that's pretty good. So not quite double, but almost there. Right? I know it's a lot. 18 years is a long time, but with a 3.5% for 18 years, you almost double the money. Now that we went through two examples of exponential growth, we now need to talk about exponential decay problems. Decay means that the value will go down. One good example of that is the value of a car. Unless it is a special type of a car, the value of most of the cars that we see on the street will go down. In this problem, the rate of decrease is 12%. Okay, so let's figure out those three variables, K, R, and T. K is always the easiest one to figure out. It's the initial value of whatever you're talking about. In this case, it's 5,400. So right now, the value of the car is 5,400. Next, we need to identify what R is. Now, to find R, before we did two things. We first converted from percent to decimal by dividing by 100. And then we added 1. Now we're going to do the very similar things. Okay, so let's walk through this. To find R, the first step is still the same. We need to convert 12% into decimal form. So how do we do that? We're going to divide that 12 by 100, which you will get 0.12. Now, next, instead of adding 1 to it, we are actually going to subtract this 0.12 from 1. And I'm going to explain that why in a minute. So we're going to do 1 minus 0.12. Now please take out your calculator. What do you get? You will be getting 0.88. That means it's 88%. Now, where did that 88% coming from? Now, just remember, in the problem, it says 12% decreasing, right? But we still want to figure out how much of the car is valued. Now, decreasing 12% means that you're losing 12% of the value of a car each year. Now, if you lose 12%, how much do you still keep it? How much do you still retain? Now, you start out with 100% of a car, but if you lose 12%, don't you have 100 minus 12, which is, don't you still have 88% of the value of the car? And that's what that 0.88 is. It's the rate of retention, how much you're still retaining, keeping with you, and that's going to be 88%. Okay, so that's the only difference there to find R. So in this case, R is going to be 0.88. And then the t is also easy. It's the time, which is 6 years. So now we can figure out y equals k 5,400 times r 0.88 to the 6 years. So let's take out your calculator and figure out. And I get 2,500, let's see, 2,507.78. So $5,400 car is going to be valued at 2,500, about half of the original in 6 years. Okay. All right, let's just do one more example. This will be the last one. I know this video has been became a little bit longer than usual, but please bear with me. Okay, so again, it's the decreasing pattern. Okay, so it should ring a bell that you should be subtracting from 1 eventually. Okay, if it's increasing, then you add 1. Okay, that's the only difference. So what is k? So the population of the town is 5,000. So k is 5,000 people. But it's decreasing 2%. So what do we need to do? Again, we need to do 2 things. What's the first thing that we have to do? We have to convert 2% into decimal, which is 2 divided by 100. What do we get? 0.02. And then, what do we need to do next? We need to subtract this 0.02 from 1. So we're going to do 1 minus 0.02. What do we get? So we get 0.98. That's a 98%. And that makes sense, right? Because you're losing 2% of the people. So what percent of the people are still in town? That's 98%. Okay. So 98.98 is going to be the R value. And T is going to be how many years? It's the time, and that's 10 years. So let's plug into the equation. So 5,000 people times 0.98 to the 10 year. So let's take out your calculator and do that. I get 4,085. Unit will be people. We're talking about number of people in town. Okay. So, well, okay, so this completes the video instruction for week 7. I hope that this instruction was helpful to you. So guys, we are almost done with this semester. Including this week, we only have 2 weeks left. I know that you have all the other classes to deal with, but please hang in there and try to finish strong. As always, please direct your question to your teacher, and good luck finishing the assignments and the quiz. Please take care.